Hi everyone, this is Adam again. So today I'm gonna go over the first chapter of probability. So just kind of going over the fundamental principle of counting. That'll sound very complicated. It's not. You won't need to know that's what it's called, but it's just basically if you have let's say two possible outcomes and then there's four possible outcomes, the total amount of outcomes is 2 times 4, so 8. So it's just that you multiply by the number of choices you have. Okay, so one example would be if I asked you, so maths, if I asked you to, how many ways can I rearrange the letters of maths and get a different word, what would your answer be? Well, the way you do this is you say, okay, well, there's 5 spaces that I want to fill. Yeah. How many different letters do I have? I have 5 letters. And therefore, for the first space, I have 5 different options. Okay? Then for the second space, so I chose one of the numbers. So 1 is gone, so I have only 4 left. So therefore, I have 4 options then for the second one. And then because I've chosen the second number, that means, the second letter, that means that another letter is gone. And therefore now I've only 3 letters then for the next one. And then 2, and then 1. And basically you just multiply all these together. And you get 120. So there's 120 different ways of rearranging maths. Okay? So that's basically the fundamental principle of counting. Is basically just you just multiply your options together. Okay? And so now I'm just going to do, just to show that this actually works, let's just say, what about arm? If I asked you, okay, how many ways can we rearrange this? Well, first of all, I'm going to do this out because here there's actually, I'll do it properly in a second, but there's only 6, okay? So again, you say, okay, well, how many letters are there? There's 3. Therefore, I've 3 different letters I can put first. But now that I've chosen one of those letters, I've only 2 left, so I have 2 second. And then I have 1. And so I have 6 different ways of writing it. And now just to show you what I mean when I say I have 6 different ways of writing it, let's start. So first of all, I can do A or M. I can flip the M and the R. Grand. So this one is when A starts. Now I could say, well, hold on, well, what if I start with R? Then I can do AM, or I can do MA. Now I can start it with M, and I can say, well, if I start with M, I'll have AR, or I can have RA. And indeed, there are 6 different ways of writing it, okay? So that's all you need to know about how we do these, is just, if you have 5 options, you put 5, you say, okay, I've used that letter, that means there's 5 letters, I've used 1, I've only 4 left, and therefore 4 goes to the next one, and then 3, and then 2, and then 1, okay? Now, another thing that I want to do is just to explain what this is. This is called 5 factorial. So 5 factorial is just equal to 5 by 4 by 3 by 2 by 1. Like so. Okay? So if we have something like 3 factorial, which is this, because it's 3 by 2 by 1. And then if we had 100 factorial, that's just 100 times 99 times 98 times times 3 times 2 times 1. So you just keep going down all the way until you're down at 1, okay? So that's what factorial is. The reason we just do shorthand, you can probably imagine if I had a letter that, if I had a word that had 78 letters, and then you were going to write this out, it would get quite painful after a while, okay? And you can always put this into your calculator, okay? So in my calculator specifically, which is a Casio one, so now it might be different for different calculators, but basically what I have is, if I pressed shift, I can see a yellow this or this. So if you see this is what you're looking for. So you type the number, then you type this thing. So for me, it's shift and then x to the minus 1. and then the number pops up. I just go equals, okay? So in your calculator, hopefully your teacher will be able to tell you that. But if you're not sure, you can just type in any number. So let's say you want 5 factorial, you type in the 5. Then for me, I have to press shift and then the x minus 1 button, there's in yellow an x factorial up here. So basically that just means I have to put the shift and then that. And then this will give me 120, which is exactly what we got up here. Okay. All right. Now the next thing that I want to do is I want to do picking. Okay. So again, this is one of those things of like you picking and choosing. I'll be very explicit when I'm doing the choosing as to what the difference is. But in this case, I'm just going to do what the picking is. Okay. So basically with picking, so you have this which is NPR, which is again in your calculator. For me, it's the shift and then the multiplication sign. Okay, and it should look something like this in your calculator. Okay, so NPR, what is this? This is just n factorial over n minus r factorial. Okay, just a bit of an awkward formula, but basically, what is it? It's basically, this is if you have n things to choose from and you're picking all of them. That's basically what it is. So let's say back up here, you'd say, okay, well, in this case, n is 5 because I have 5 letters and r is also equal to 5 because I'm picking 5 of them. Okay, so if I was only picking 2 of them, so let's say I said, okay, how many 2-letter words can I make using the word maths? You'd say, well, I have 5 letters to choose from. But then in this case, you'd say I'm only picking 2 of them because I'm only making a 2-letter word. Okay. So let's plug that into this formula. So let's say I said, okay, I want to make, I have 5 letters, so maths. And I want to make a 2-letter word. So how many 2-letter words can I make? You'd say, okay, well, if I plug 5 in here and then 4 here, I just simply get 20. Grand, that's fine. Now let's plug it up into our formula. So in this case, n is 5. R is 2 because I'm only picking 2 of them. So it's 5 factorial divided by n minus r. 5 minus 2 is 3. So this is 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1. So the 3 times 2 times 1 and 3 times 2 times 1 cancel. So I'm simply left with 5 times 4, which is 20. So just to be explicit, both ways work fine. Okay, so you can use this formula in your calculator if you would like, and you get the same answer, but you also don't have to. Okay. All right. So now I think I will do, I'm going to do, also, sorry, one thing that I want to mention as well is that 0 factorial, that's equal to 1. Okay. The basic idea of this is just, you say, okay, well, if I have, because again, this is looking at how many options do you have. So if I have 0 options, then the idea is that there's only one thing I can do, and that's do nothing. So there's only one thing I can do. Okay. That's basically the idea. Okay. And 1 factorial is also equal to 1. By saying that 0 factorial is equal to 1, it just makes our life easier, basically, to be quite honest. That's kind of what's going on. So, yeah. All right. Okay. So I'll just leave that at that, and I'll go on to an example. So here it says, how many numbers between 500 and 1000 can be made between the digits 2, 4, 6, and 8? And it says, if no digit may be repeated, okay? All right, that's fine. So you just can't repeat any digits. Grand. So if you can't repeat any of the digits, then we have to make, so the number has to be between 500 and 1000, and therefore it has to have 3 digits. Okay, so it's between 500 and 1000. So obviously all the numbers between 500 and 1000 have 3 digits. Okay. So first of all, so now this is when we start to use constraints, okay? And that's always what you do first. So first of all, what number do I have, what numbers, so again, you can pause the video and think about it. What numbers have to go first in the digit here? The answer is 6 and 8. Because if I put a 2 there, I'm going to have 200 and something. That's less than 500. If I put a 4, that's 400 and something. That's less than 500. If I put a 6, that's 600 and something. That's over 500, but less than 1000. The same thing with 8. 800 is above 500 and less than 1000. Okay. So basically, I have to use a 6 or an 8. So even though there's 4 numbers I can choose, I'm only allowed to use 2 of them because I want them to be between 500 and 1000. So I only have 2 options for the first digit. Okay. Now, how many different digits can go in the second one? 3. And then 2. Okay, so again, I can only use 6 or 8 here. So what can go here? 6 or 8. Great. But now here, any number can go, except the first one. So if the first one, if I chose an 8, I can use 2, 4, or 6. If the first one I chose as 6, I can do 2, 4, or 8. And that's fine. So again, for these ones, I can choose any number as long as I didn't use the one that was previously used. Okay. So this now is just going to be 2 by 2 is 4 times 3 is 12. So there's 12 different ones. Okay. And then it says, what if the digits can be repeated? So now you can repeat digits. So again, you say there's only 2 digits I can put in the first one. Grand. But now I can repeat digits. So now I actually don't care that I use a 6 or an 8. I can use all 4 of them again. So I can use all 4 of them and then all 4 of them again. So that's fine. Okay. So I get 32. So this is if you can't repeat digits, and this is if you can. Okay. And yeah, that's it. Okay. Now with these ones, I think this sort of probability, it's much more important to do questions. So obviously I'm going to do questions here, but it's very important that you do questions yourself. Because it's a thing of, you'll watch me, probability is one of those things that you'll hear me explaining why I'm doing what I'm doing, and you'll sit there and say, yep, that makes loads of sense. And then you'll attempt to do a question and you'll say, oh, whoa, what's going on here? This is different. You know, it's one of those things that you have to have practice in it, or you will find probability very hard. Okay. Now, some people find probability really easy. Some people find it very hard. But just once you do a few questions, you'll recognize when the questions are the same and how you basically approach them. Okay. Okay. So first of all, I'm going to do this question here. So it says, how many ways are there of arranging the letters of theory if the letters are taken 3 at a time? So if I just take 3 of them, how many different ways can I do it? Well, you'll say, okay, well, first of all, how many letters are there? There's 6. There's 6 letters, so I can choose 6. And because I've chosen one of them, there's only 5 left. And now I've chosen 2 of them, so there's only 4 left. Okay? So that's going to be 120, I think. And just for the record, if you wanted to use the picking formula, you could. So again, this is NPR. N is the number of letters you can choose, and R is the number of letters you're actually choosing, which in this case is 3. And if you plug this into your calculator, you will indeed get 120. Okay, now, so this is always an option, but I'm going to do all of them this way because I think it's much more important for understanding than just saying, oh, I just plugged them into a formula and I get the answer. Okay, so you can always do these out by hand because all of these will be short enough that you can do it out by hand. So that's the only reason I'm doing it, because it makes a lot more, it just makes it nicer. Okay, and now this one says, okay, well, what if you do 4 at a time? So now it's 6 times 5 times 4 times 3. Because again, I have 6 letters, 3 of them are gone. So what goes here? 3. So it's going to be 360, which is again equal to 6p2. Okay? And then it says if it's 6 at a time, so again, it's 6, 5, 4, 3, 2, and 1. So it's 6 factorial, just to be clear. 6 by 5 by 4 by 3 by 2 by 1 is 6 factorial. And that's equal to 720, I think. Yeah. And that's equal to 6p0. Okay? Remember, 6p0 is equal to 6 factorial. Sorry, 6. Sorry, this should have been a 6 here. Sorry, because I'm picking 6 of them. Sorry about that. So then this is going to be 0 factorial down here. And remember, this is just equal to 6 factorial. Why? Because 0 factorial is equal to 1. Okay? All right. Okay, now this is one of the other questions that I want to do, which is quite hard. But, once I go through it, hopefully it won't be too bad. So it's, how many ways are there of arranging the letters of the word monster? And then it'll give us some conditions. So remember here now there's 7 of them. 7 letters, okay? And it says, first of all, if there are no restrictions. So first of all, you just have, so there's 7. So you have 7, 6, 5, 4, 3, 2, 1. So it's just 7 factorial, and that's equal to 5040, I think. So again, that would be 7p7, because I have 7 letters to choose from. I'm picking 7 of them. So if you plug that into your calculator again, you will get 5040. Now, this is when we can't use the formula after this, okay? So it says, how many ways are there of arranging the letters of the word monster if it must begin with the vowel? Okay, so again, you have 7 letters. And it says it has to start with a vowel. So first of all, where are the vowels? We have 2 vowels. So it has to start with one of them. So this is your constraint. So basically, this is the same what you have to do. So you always do that first. Okay, you always decide, okay, what conditions do I have to meet first? And then you do the rest of them, okay? So you don't do, oh, it's the first letter, so let me pick this one first. No. You always, when you're doing these, you always pick the constraint first, okay? So here it says it has to begin with a vowel. If it said it had to end with a vowel, I do the exact same thing. I'd just be putting my answer down here instead, okay? So it has to begin with a vowel. I have 2 vowels, therefore I have only 2 options. It can either start with an O or an E. Grand. But now I couldn't care less what happens after that. Why? Because here we say I can choose 6 letters, 5, 4, 3, 2, and 1. So this is going to be 720, so 1440, I think. Like that. Okay? So again, hopefully that makes sense. That basically you just say, okay, the only thing that's different from the top one to the bottom one is this one has to start with a vowel. So it has to have an O or an E starting. And that's it. Okay? The next one it says, if they must begin with a consonant. So a consonant is just not a vowel. So again, how many not vowels do we have? We have M, N, S, T, and R. So there's 5 of them. And then again, everything's just the exact same. Nothing changes. And if you do this out, you will get 3,600. And if you notice, if I add these together, I actually get 5,040. Why? Of course I do. Because these are numbers that start with a vowel. These are numbers that start with a consonant. Of course, all words have to start with a vowel or a consonant, and therefore, if I add them together, I have to get the total amount. Okay? So, just for the record, to get this one, I could have also done the total amount minus the number that start with vowels. And I would also have gotten 3,600. Okay? So there's two. So again, nesting and probability, sometimes it's easier that like, okay, it'll come later down the line, but just sometimes it's easier to say, instead of calculating something straight away or directly, you can say, well, is it easier for me to calculate the chance of this not happening, you know? And sometimes it is. Okay. And then it says, part 4, it says, how many different ways can you do it if the vowels have to be together? Okay, this is quite hard. Okay, so I'm going to try and explain this properly. So basically, if the vowels have to be together, you can basically take that as being a letter. Now that might sound a bit stupid, but basically, so up here we're saying, okay, there's 7 letters and I'm picking them, grand. If the vowels have to be together, there's 2 of them that have to be together. So instead of 2 letters, I just take that as a singular letter. Okay? So now I have only 6 things that I'm picking. Okay? So again, it's like you have M, N, S, T, R. And then I'm taking O and E as like a block because they have to go together. No. This is fine. It's this that I want to do. So basically, because these have to be together and therefore I can just take them as being like a block. So like a block to just slot in and that's that. Okay. So now I can say, okay, well now I've 6 different things that can go first. So I have 6, then 5, then 4, then 3, then 2, then 1. Multiplied by 2. Now, try and think. Again, just pause the video. Why did I multiply that by 2? Because I didn't do that anywhere up here. I've only done it now. So why have I done it now? The reason I've done it now is because I never said, was it O or E or was it EO? So it could have been OE or EO. And therefore there's 2 ways. There's 2 ways of rearranging the letters O and E. And therefore whatever way I've done here, I need to multiply it by 2. So this now is going to be 6 factorial times 2. Or 2 factorial. Because this is just the way I can arrange 6 letters. This is just the way I can rearrange 2 letters. So then 6 factorial is again 7,200, so it's 1,440. And then the very last part, it just says if the vowels must be apart. So how many are the vowels apart? Well, here we have, that's how many the vowels are together. So if the vowels have to be apart, then you'll basically just do 5,040, because that's the total amount, minus how many where the vowels are together. So I'm just left with 3,600. Okay. All right. So that's kind of that. Okay. Okay. Now, I'll do another, maybe 1 or 2. So yeah, so I'll do this one. So it says, how many ways are there of arranging the letters of the word triangles? So again, this is exactly what we were just been doing. So it's 3. So there's 9 letters here, okay? And it says if there are no restrictions. If there's no restrictions, again, you just have 9 letters, so it's just 9 factorial. And whatever that equals, okay? So nothing too extravagant. It says, what if the 3 vowels have to be together? So now, the 3 vowels. So these are the consonants. These are the vowels. So again, you take them and you say, okay, well, here are my consonants, which are T, R, N, G, L, S. And I'm going to take I, A, and E as a block because they have to be together. Okay? So now you can imagine I have 1, 2, 3, 4, 5, 6, 7. So I have 7 things that I'm going to rearrange. Okay, so again, I have 7 things. So I have 7, then 6, then 5, then 4, then 3, then 2, then 1. And then I have to multiply this by how many ways can I arrange I, A, and E? It's going to be 3 factorial. So 3 by 2 by 1. So this is just 7 factorial multiplied by 3 factorial. Okay? And that's it. All right? So that's how you do one of those. And then here it says, what if the 6 consonants have to be together? So now, if the 6 consonants have to be together, it's going to be T, R, N, G, L, S as a block. And I have I, A, and E over here. So now, how many things do I have? 1, 2, 3, 4. So now I'm only picking 4. 4, 3, 2, 1. Multiply it all together. Multiply by how many ways can I rearrange 6 things? I can do it 6 factorial ways. So this is just 4 factorial multiplied by 6 factorial, like that. Okay? Okay. Hopefully that's okay. And now this one says, what if the letter G must be immediately followed by the letter R? So again, now we're taking G and R as a block. Sorry. So now G, R are a block, and I still have all the other letters. Sorry, and an E as well. So I still have all the other letters. So again, it's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 factorial. And that's it. So up here, I had to multiply by how I'm rearranging the block. Here I don't, because I'm told specifically that the letter G must immediately be followed by the letter R. So I have to have GR. So RG doesn't work. So the answer is simply this. Okay? And then finally, it says, what if they must begin and end with a consonant? So again, do your 9 things. So if it has to start and end with a consonant, you say, okay, well, how many consonants are there? There's 6. So I have 6 different options for the first number. And I have 5 for the last. Okay, that's very important. So you always do the constraint first. So they tell you that it has to begin and end with a consonant. Grand, you do that first before you do anything else. So you say grand. So the first one, I have 6 different consonants, so therefore I can have 6 different things. For the last one, I've picked one consonant to go first. So I have only 5 left. And therefore I have 5 options for the last one. Okay? So now I've picked 2 letters. There's 9 letters in total, so there's 7 left. So I can do 7, 6, 5, 4, 3, 2, 1. So this is just 6 times 5 is 30, multiplied by 7 factorial. So 7 factorial is just in here. Okay? So hopefully that's all okay. All right? Sorry, I'm just looking at the other ones. Yeah, to be honest, I think that's enough. I think that's about as hard as a question you're going to get with triangles, to be quite honest. So if you can do one of those, I think you're flying it, to be quite honest. Okay? And the next thing I want to do is choosing, okay? And so choosing now is much different to picking, okay? And I'll explain the difference once we get on to one of the questions as to why I want to use choosing instead of picking, okay? So the choosing formula, which is going to be NR, which is NCR, which is n factorial all over r factorial into n minus r factorial. So it's basically just equal to NPR divided by r factorial. That's basically all it is. Okay, so you just have an extra r factorial over here. All right? Only difference. Okay. So now, let's do... Yeah, okay, so let me just explain when I want to use picking and when I want to use choosing, okay? So the difference between picking and choosing is basically, it comes down to, if you're sitting there and you're saying, okay, do I care about the order or do I not care about the order? And you might say, well, that doesn't make any sense. When I say that, I mean, if I asked you, there's two people on a committee. So let's say Alice and Bob, is that a different committee to Bob and Alice? No, it's not. That's the same committee. And therefore, when it comes to committees, I don't care about the order. All right? But if you told me, you were like, hey, Adam, my BankLink 4-digit code is 1234, and you give me your bank card and I want to withdraw money, if I put 4123, I won't get in. So when it comes to codes like your iPhone and your BankLink and these sort of things, the order matters. So if you rearrange them, there is a difference. Okay, so that's the thing. That's the thing with choosing and picking. If you're choosing, you don't care about the order, which basically means that if you start to rearrange things, it'll make no difference. Okay, but obviously with a word, if with this word that I wrote up just up there in red, choosing, if you flip the G and the C, all of a sudden it becomes not a word. Okay, so the order of words matter, the order of numbers for passwords matter, the order for something like a team or students or a committee wouldn't. Okay, so that's the main thing to do. Okay, all right. So for one of the questions, I think this is best described using an example. So here it basically says, a manager names a panel of 15 players for a hockey final. On the day of the final, he must choose 11 players. How many different teams could the manager possibly select? Now, this is worth noting. In all of these, we are not considering the positions. So basically, if you have like, just say in, soccer or football or whatever, if you had, if you swapped the goalkeeper and the left back, that would still be the same team. Okay, so when we say the team is different, we specifically mean you've taken a player out and put a different player in. Okay, so now, the way you do this is, so you're picking 11. So first of all, I'll do it out properly, okay? So you're picking 11 players. So 11, okay? And you have 15 players to choose from. So theoretically, I have 15 different options for the first guy. I then have 14, then 13 and 12, all the way down to 12, 11, 10, 9, 8, 7, 6, and 5. Okay, sorry, I might just write everything in just because. Okay, so that's what it is. So exactly what we were just doing, everything is fine. This is when things get hard. I now need to divide this by 11 factorial. And again, try and think, if you want, you could just go back, 2-3 minutes in this video and see like what I was saying about the picking and choosing, and why I don't care about the order, why I now have to divide by 11 factorial. The reason is basically because I have 11 players. I need to divide, so basically by doing the 15, 14, 13, 12 thing, what I've counted is I've counted all the possible teams and all the possible ways of rearranging them. So remember, this is exactly what we were just doing up here with the different words. Okay? The difference is that now I don't want to count if the players are moved around. I want to get rid of that. Okay? So what I need to do is, so once I calculate, I say, okay, this is the total amount of different teams I can have. Grand. Now I need to say, okay, well, hold on. How many ways can I rearrange 11 players? So how many ways can I rearrange 11 players? 11 factorial. I now need to divide the answer that I got by 11 factorial because that's how many I've extra counted. Okay? So hopefully that makes sense. I'm going to do a simple, so again, just for the record, this is 15C11. So there's 15 players, you're picking 11. That's equal to this, 15, times all the way down to 5, divided by 11 factorial. Okay? So you can also use the choosing thing here. But let's just say I've 2 people for a committee and I'm picking 2 of them. Okay? How many different committees can I make? The obvious answer is 1. Okay, so let's just say I have Alice and Bob. And I'm picking 2 people to represent the committee. Of course, there's only one committee I can have, and that's Alice and Bob. Bob and Alice isn't the same thing, okay? But if we keep going with the way we had been going, we say, well, okay, there's 2 people. So I can choose 2 people for the first one, and I can choose 1 person then for the second one. Grand. That's equal to 2. Now I need to divide this by the number of ways I can rearrange 2 people. Okay? How many ways can I rearrange 2 people? 2 factorial. That's just 2 divided by 2, which is 1. So that's what you're doing when you're dividing by this 2 factorial or 11 factorial. Okay? Yeah. Okay. So again, I might say, okay, well, what if we have Alice, Bob, and say Cathal or Connor? So now you have 3 people, and now it mightn't be as obvious, but how many different committees can you make if you're picking 2 people? The answer is 3, because the first one is leaving out Alice, the second one is leaving out Bob, and the third one is leaving out Connor. Okay? So there's 3. So the answer I should get is 3. So if we do it now, I'm doing a committee of 2. How many options do I have for the first one? I have 3, and then I have 2. So I get 6. I need to divide this by the number of ways I can rearrange 2 people, which is 2 factorial, which is 6 divided by 2, which is 3. So that's what you're doing here. So when I went up to this hockey thing, and I was saying, okay, well, how many different options do I have? Like 15, 14, 13, 12, whatever. You multiply them all together, grand. And then you divide by 11 factorial because that's the number of ways you can rearrange 11 people. Okay? So that's why this 11 factorial appears up here. Okay? So hopefully now that's not too bad. Okay. So now I'm going to do maybe 2 to 3 questions. How much do I have left in this chapter? Okay, I still have a decent bit to go on. I'm kind of nervous that the video has already been a little bit long. But yeah, I think we'll just plow through. Okay, so let's come down here and it says, so there are, so a class consists of 6 girls and 7 boys. A team of 4 tennis players must be chosen from this class. How many different teams could be picked? You would say, okay, so if there's no restrictions, how many different teams could be picked? You'd say, grand, so you have 6 girls you've 7 boys, and you're picking 4 people. Grand. Well, the simple thing is, you've 13 people, so you've 13 to choose from. Then you've 12, then you've 11, and then you've 10. And then you want to divide this by how many different ways can I rearrange 4 people? 4 factorial. So that's it. Okay, so that's how you do something like that. All right. And then it says, it's a team must have 2 girls and 2 boys. So you must have 2 girls and 2 boys. So this now, I'm going to start assuming. So I'm assuming that the boys will be first and then the girls will be second. Okay. So, how many different options do I have for the boys? I have 7 and then 6. And for the girls, I have 6 and then 5. Now try and think. I need to have 2 girls and 2 boys. What do I have to divide this by? Because the answer is not 4 factorial. What do I have to divide this by to avoid double counting? Okay, so again, think about it. I need to divide it by 2 factorial because these boys can be switched around. And then I need to divide it by another 2 factorial because these girls can be switched around. Okay, so when I've picked this arrangement, what I've done is that I've assumed the 2 boys have gone first, but I haven't said, oh, well, I've counted that if I have Connor and Adam, that's the same thing as Adam and Connor. There's 2 ways of doing those, so I need to divide it by 2 factorial, okay? And then the same thing with the girls, okay? So this is quite difficult, okay? Just to remember these things, that basically up here, I could have had any arrangement of girls and boys. Here, I specifically chose the boys to go first and the girls to go second. What you're trying to do is you're trying to avoid counting too much. So up here, I needed to divide by the 4 factorial because that's the many ways I can arrange 4 people. Here, I need to divide by 2 factorial because that's the way I can rearrange the boys. And then here, that's the way I can arrange the girls. Okay? So when it comes to choosing, you're absolutely fine with like picking the boys to go first or the girls to go second or vice versa. You get the same answer. Okay? Because you're always trying to stop yourself from counting more. The whole thing with choosing is that with just a simple calculation up here, I have included the boys going first, the girls going second, the girls going first, the boys going second, 1 boy going first, second girl, whatever, and so on and so on. You've counted all of those, but you want to uncount them. And that's what this dividing by 4 factorial does. Here, I have assumed that the first 2 are boys, and therefore I only have to divide by 2 factorial. And then the same thing with the girls. Okay? So hopefully that makes sense. Okay? And then for the very last one, it says, how many different teams can be made if all of them had to be female? So again, you've 4 girls. There's 6 in total. So you've 6, 5, 4, 3. And then you divide this by 4 factorial because that's the number of ways you can rearrange 4 girls. Okay? All right. So hopefully that's okay. I might just do one more and I think I'll leave the choosing. What else do I have left in this chapter? Okay, yeah, that's fine. Okay, so here it says, in how many ways can a committee of 5 be chosen from 11 people if one particular person must be included? So again, you'd say you're picking 5 people. You have 11 to choose from, but one of them has to be picked. So again, one has to be picked. So you're picking him and that's it. That means there's only 10 left. So again, you've 10, 9, 8, 7. I now need to divide this by 4 factorial because that's the number of ways I can rearrange 4 people. Okay, now remember, I'm not dividing by 5 factorial. Why? Because the person that I'm picking, I'm putting him first. So this is basically me saying that he's guaranteed on the committee. So that's fine. So I only have to divide by 4 factorial because there's 4 ways of arranging these people. Okay? And I want to get rid of the arrangement. Okay? And I get rid of it by forcing the person we're choosing to go first. So therefore, I don't have to divide by 5 factorial. All right? And then it says, if one particular person is included. What if one particular person is excluded? Well, that's almost easier. Because there's 11 people, you're excluding one person, so you only have 10 people you can actually choose. So 10, 9, 8, 7, and 6. And then you divide this by 5 factorial because that's the many ways you have of rearranging 5 people. Okay? All right. So the next one, it says, which is quite hard. This is the most complicated one out of all of them. It says, if 2 particular people will not work on the same committee together. Okay, so if one is included, the other must be excluded. Okay. The easiest way of doing this is saying, okay, what can happen? So you can have one included, or both excluded. So those are your 2 options. So either you have one of them or you don't. So first of all, let's do this first. What if both are excluded? So there's 11 people, we're not choosing these 2 people, so I have only 9 people to choose from. So again, it's just 9, 8, 7, 6, 5. You divide it by 5 factorial. That's it. So that's if they're both excluded. So now for the second one, what if one of them is included? So now you're 100% picking one of them. And that means you can't pick the other. So you have 9 options left. Okay? So you have 9, 8, 7, and 6. And you need to divide this by 4 factorial because that's the way of arranging these people. Okay? All right. So this... Okay, so I'm actually not sure what this is, to be honest. 9 shift C 5. So this is 126. Does that make sense? Yeah, it is. Okay, that's fine. And then this then is going to be, I feel like it's the same thing. Yeah, it is. That's also 126. So this is the number of ways you can have if both are excluded. This is the number of ways that you have if one of them is included. But remember, there's 2 of them. So you have to multiply that by 2. Okay? So hopefully that makes sense. Because obviously, this is if I choose, again, if it's Alice and Bob, this is me assuming it's Alice, then it's 126. And then if I assume it's Bob, it's another 126. 126 plus 126 is 252. So the total amount then is 252 plus 126. And that's going to be 873. Like that. Okay? So yeah, hopefully that's okay. Yeah, which I think I might leave it there for this video anyways, and then yeah, so that's the choosing. I'm going to want a relative frequency and then some of the intersections then in a second. Okay, so yeah, I think I will leave it at that for me a few minutes, but anyways, until the next video to finish up on the rest of this. So yeah, thank you very much for paying attention, and I think I'll see you in the next video.